Welcome to my channel, Dr. Munshi Nasser Skill Tone. My dear friends, today we are going to talk about the fourth question of our basic statistics. So let's go and see the fourth question. This is the fourth question we are talking about. First two questions were discussing about descriptive statistics, chi-square, how to do this using BlueSky and R platform. Question 3, the last video was talking about the correlation between the income and life expectancy, and also we have seen how R and the BlueSky does a very good job. And today's video is talking about the question number 4, which is the final video of this playlist. Is the are you more likely to receive imprisonment for a crime in different regions of USA? So whether there is a two states, for example not Alaska, let's say Minnesota, and the northern part is Texas. So these are the two states in USA, and now you're talking about whether if you are traveling to south, whether if there is a provision, the crime that you are committing in south gives you a penalty of imprisonment, where the same crime does not give you any penalty for other regions in the United States. In that case, what is the likelihood that you will commit a crime in USA if you travel to south? So are the differences between regions statistically significant? Are the differences between the regions statistically significant? So these are the important questions. Are you more likely to receive imprisonment for a crime in different regions of USA? So these are the question, and for this particular question we try to answer using t-test, and for non-parametric test we are going to talk about in other video, but today's video is talking about the t-test, and we are using BlueSky statistics and R platform. So let's see how it works. Now to begin with, for this t-test we just go to the file, load dataset from a package. It's a very good option in BlueSky statistics where you can load any package you want, and this is a good platform. And one of the other thing I strongly like is that even if the package is not available inbuilt in the BlueSky statistics, you can import it from the screen using the tool option. And you can see here that in the tool option there is an option called packages, and you can see here that install packages from zipped, install update packages from cran. So if you would like to do something outside of the BlueSky statistics platform, you can always install the package using the install update package from the CRN. So it's a very nice option in the BlueSky that you don't need to use any other platform like RStudio. BlueSky itself can give you everything that you need, primarily for the beginner and to the advanced level. I mean, there is a machine learning option in the BlueSky statistics, which is fascinating because normally we tends to find some very complicated coding for the machine learning, but in BlueSky it has a drag and drop option, and I will talk about the machine learning application in some other video in my channel. So stay tuned and subscribe if you do want to get those videos notification quickly. Anyway, so go to the file menu and then you go to the load dataset from a package. Okay, and then as I said, you can type here that MASS. This is the package we are talking about, MASS. And the dataset we are talking about, the US crime dataset. Okay, so if I say US crime dataset, let's see whether it is there. Yes, you can see here the US crime dataset that we are talking about for the example of this particular video. Press OK and you will see the dataset will appear in a second in the BlueSky statistics. So now you can see that there is a variable of interest. In our case is the one that we are talking about, the south. So if you go to the south it is 1. If you don't go to southern region, then it is 0. So it's a coded variable, and if you'd like to know more about this variable, go to the variable view and you see here that south integer, and if you press is, because it is an inbuilt dataset, so it doesn't have the value that I already mentioned. It's already updated in such a way that is already there, but you can see the data view, it gives you some information about the data structure. So dataset is about the south that we are talking about, whether you are moving to the south, and the probability of having the imprisonment. This is the question that we are talking about. Okay, so the probability variable is also an important here, the probability, and traveling to south and not traveling to south. So these are the two things that we're talking about in this particular case. So let's see how the t-test can work. And normally t-test, why t-test is important? T-test is very important because of the difference between the mean of the two groups. The common activity in research is the comparison of two groups. This is our common activity in the research. Like, do patients receiving a new drug show greater improvement than patients using an existing medication, like the question I did in the US crime said, or does one manufacturing process produce fewer defects than another? So there are two groups that we are comparing. Which of two teaching method is most cost effective? So if your outcome variable is categorical, like the one that we are having, South 1010, you can use the method described like the one that we discussed in chi-square test or other contingency table. But if it is a continuous variable, like the one that we have probability of continuous variable, in that case we can use the normal distribution, and most of the cases we can use the t distribution or t independent t test. So these are basically showing the two group mean, and these two group mean whether it is same or different. These are the two things that we are discussing. In the chi-square test also we have done whether there is an association between the two groups, like the one that we have south and probability, or there are income or unemployment. There are two variables in the macro context, whether these two groups are associated with somehow dependent each other. So we can find out using chi-square. Same way in the t-test we would like to see whether these two variable are having the same mean or different mean. So we are testing about the mean and using the t statistics for this region. So go to the analysis and you can go to the means and then t-test independent sample. If you click that one, okay, then we have south. Click this one and the selected factor variable with only two levels. Let's assume that, okay, let's assume that probability. Go to the probability one, probability one, and it says single factor variable with only two levels. So in this case we can see here 1010, right? So in this case we can choose south. Okay, so let's choose south here, and our null hypothesis is that these two groups, southern visit and the probability of imprisonment, these hypotheses, they are having equal probabilities. The mean are equal probabilities. So the hypothesis is southern states and non-southern states have equal probabilities of imprisonment. So our null hypothesis is, I repeat again, southern states of USA and non-southern states have equal probabilities of imprisonment. Our alternative hypothesis, which is mentioned in the here in the box, that they are not equal. This sign means not equal. These two group or two variables are not equal. Now let's press OK and see what happened. Now you can see there the BlueSky statistics give you a very nice outcome of the table where it says that the probability of these two are showing significant. If you go to the significance level, it's that they are very highly significant, which is 0.001, both 0.00 and 0.001. So they are highly significant. Okay, they are highly significant. So which means that since it is highly significant, these two samples, so we can reject the hypothesis. We can reject the hypothesis, the saying that southern states and non-southern states have equal probabilities of imprisonment. We can reject that hypothesis and we can accept the alternative hypothesis, meaning that they do not have equal probabilities. Okay, we can reject the null hypothesis which says that southern states and non-southern states have equal probabilities of imprisonment, but we are rejecting that hypothesis. We are accepting the hypothesis where it says southern states and non-southern states have not equal probabilities of imprisonment. Because as you know, if southern states have this kind of crime, there is an imprisonment option, obviously then the value of the two groups will not be the same, and that is the result we are looking at. But the main idea behind is that we'd like to know if we can see for the main reason of the t-test, if we can look at using this nice pencil where this value, this value, this test value, it says the significance. So whenever anything comes significance in the t-test, you will reject null hypothesis. Okay, because its significance, meaning that it is significantly different than 0. Okay, so there is something, okay, to mention, that's why we are rejecting the hypothesis, null hypothesis, and we are expecting or accepting the alternative hypothesis. So if it is significance, reject null hypothesis. If it is not significant, accept null hypothesis. That is the idea behind our t-test, to see the association between the two groups of variable, whether they are mean or equal or not. So if this is so, then we can always go back and see another analysis, go to the mean and see the t-test independent samples, two numeric variables, t-test one sample, paired samples, let's say one sample test if we like to say, same way. Okay, if we go to the analysis and see the means paired sample, you see the paired sample, first variable, second variable, you can choose like the same way that I showed you. Analysis, go to the t-test, again mean, and if you'd like to see the numeric value here, so now you can have first numeric variable and second numeric variable. So if both are numeric variable, you can put like this way. So the main reason behind the t-test, as I told you, that you need to see whether these two group of variables means are equal or not. If it is significantly different, then you reject the null hypothesis and accept the alternative hypothesis, and saying that yes, the t-test is coming that these two groups are not equal, like that. So this is the main idea behind the t-test. So one thing I would like to mention here, that what if instead of having two variables, if we have more variables and we would like to compare those means, like for example here it says southern group, and then we have a probabilities. Let's assume that we are using income level differences of the states or unemployment level differences of the states. In that case, what will happen? What kind of methodology we are going to use? So to do that, my dear learners, we are going to use one of the most popular methodology called the ANOVA. Okay, so if we have a more than two groups to compare the means, the ANOVA is the best way to analyze your comparing mean group statistical significance. So when we use ANOVA, when we have more than two groups comparison of the mean. If you have a two group comparison of mean, then and it is normally distributed, then t-test is fairly okay. And the other one is here, the sample size is 31. So it means that the number of sample, if it is less than 30 or close to 30, we can always use t-test. Otherwise, we can go for z-test or normality test, or as I said, more than group 2, we can apply the ANOVA for our analysis to compare the means of the different groups of the observation. So with that note, I hope you like my video, and as I told you that our BlueSky GUI has a different option like the our syntax code. So assuming that we'd like to see the syntax of this same command, so go to the mean again, use the t statistics, probability and sample, and press syntax. Once you press the syntax, you will see the syntax variable appear in the right hand side, and where the commands of the R is already displaying in the BlueSky statistics. So all you have to do, if you run the t-test using the first you use the object, then you use the name of the function that you are going to use. In this case, t-test is the t.test is the one that we are talking about, t.test, the function that we are using for BlueSky to execute the command. And then if you select the whole thing and then run, and you will find the same thing. I mean, at the bottom you will see the same outcome that we have with the drag and drop menu. So this is a very nice platform. Like, see here it appears like the same way we have appeared in the first part of the option. So it's a very nice way to produce any R code at the same time using drag and drop option, so that both the option you can use for your study and data analysis purpose. So with that note, I guess the whole playlist is for to show you how the basic statistics works, what are the questions we might ask, and how to apply BlueSky and as well as R code to use and solve the statistical questions like these for your research question or research objective, and how to interpret the results as well. So if you like the effort that I am putting in this type of videos, and if you like the content, of course do subscribe to encourage me, and of course you can give your comments to the description box, or I mean the video in underneath of the video. I'll get back to you for your any queries. So thank you so much, and until then I will see you in the next video. Bye bye.